Let's do a quick round of introductions, starting at the front.
I'm Brian O'Hora. I'm the Executive Director for Catalina Marketing. In that role, kind of focus on new data science capabilities. Catalina Marketing, we do personalized digital media powered by the world's largest shopper purchase history database.
I'm Charles Cox. I'm a data scientist at Allstate, where I work on primarily modeling and the automation team, so working on automating the process of fitting and creating our models.
Sri, founder at H2O.
Brendan Herger, data scientist in the Data Innovation Lab at Capital One. We do credit cards. You've probably heard of us.
Connor Jensen at Zurich Insurance. We do commercial property and casualty insurance here in the States and around the world. I run the analytic operations team, which is a multidisciplinary team of data scientists and other data experts that is kind of we build all the capabilities, we are maintaining the platform, and we are the interface between the analytics group and the operations team that support us.
And I'm Tom. I run customer engineering at H2O.
Thank you. So let's open the field. I mean, the topic is what's the culture of a data-driven organization? I'm gonna start off with Brian. Say, what is the ideal mix? I mean, everyone is obviously investing in data-driven, building a data-driven organization. What mix of data scientists, data engineers, software developers? What do you need? What is the right mix?
Sure. I think it starts maybe above that, kind of with the senior leadership. I think having those folks engaged and understanding the value of maybe competing with algorithms, machine learning. I think at Catalina we have that. Have a CEO, a chief data officer, and a recent chief product officer we brought in from Google, who really kind of set that vision. That really, not only the vision, but that helps with your budgeting and your roadmaps. Kind of more tactically, I think from data science, we really want to keep those guys embedded with agile teams. So from that perspective, maybe the mix start with for applications where it's a true data product, that kind of 1 to 4 maybe data scientists to developers. Not so much a formalized data engineering role. I think that falls to our developers. From a DevOps perspective, I think that really depends on how mature your continuous integration is, but maybe from our perspective, maybe a 1 to 10 in that team mix.
Connor, do you want to chip in? What's your sense at Zurich?
Sure. So honestly, I think it's still, there's kind of two layers to this to me. One is really that sense of what is the mix from your analytics developers, and then what's the mix on the operations side from the IT to actually support that. I think we're still trying to get that balance right, to be completely honest. I think right now if I was completely honest, I'd say we're a little heavier on the science and the analytics side, and we are working on building out a better support team. And part of it, so you guys, most of you heard Dave talking about this earlier, moving to open source creates a very different environment from an IT and a support perspective. We are doing much more in-house than we had done previously. And so, as we are trying to make that shift to using open source, R, Python, H2O, things like that, we're taking on more ownership, which I think is fantastic because we have much more flexibility within that data science group to try new things, do new approaches, do algorithms, tackle new problems. But the challenge of maintaining, supporting, and actually pushing those to production, we're having to beef up really on having a different relationship with IT. And I think we're still getting there.
And Tom, I want to get your perspective from a vendor side. I mean, you talk to customers all the time, and when you talk to an organization, what do you feel are the gaps in some of the companies? And
yeah, I think one of the reasons that people like working with us is because we can speak to both of those types of folks, the data science folks, the data engineering folks, the software engineering folks, the DevOps people. My sort of quote unquote best advice is for an organization is to make sure that these people are talking to each other. And a lot of the times they're not, and a lot of the things that need to improve start with that, right? It's just communication internally. And one of the things that I think people like to work with us, one of the things that they definitely benefit from working with us is since we can speak all of those languages to be able to kind of make their own internal communication better as well by just plugging this in.
Sure. Actually sort of brings up a question. I mean, and I guess we see it all the time, is hiring data scientists is such a difficult task for most companies, and it's often a challenge. And I want to bring in Brendan for his perspective, and what can organizations do? How do you optimize your data scientists, the data scientists you have, and how do you make your organization attractive for new data scientists?
Yeah, that's a great question. So I think kind of 2 points, like to bring in data scientists is kind of hard, especially given how the market is right now. But it seems like it's really valuable to at least have interesting problems that people want to work on. You can't really teach people to be motivated or to do things interesting. And so it's been kind of interesting to try to find folks who do things on their own or are learning on their own and just be able to support them. Because if someone's really passionate, then it's easy to put resources behind that. I think you get a lot more out of it than you put in. Not that that's necessarily the right way to go about it. And then in terms of structuring the organization, two better support data scientists, it's kind of a hard question because there's really the two extremes. Some companies are sort of the monolith of data science, and there is a data science team which you lob a question over the wall to, and then they lob an answer back. And in many ways, it is more effective, but then actually getting it integrated is more difficult. Whereas the more embedded model of having a data scientist with every team means that your resources are much more spread out, and it's harder to get uniformity across data scientists or groups like that. So it's a difficult question.
Charles, what's your thought? How do you?
So I'd say that I think from my perspective, I'd agree firstly that with the first contingent to attract data scientists have interesting problems for them to work on. Personally, I think at Allstate we work more with the group. There's a single group which has most of the data scientists, and I think that's useful because it permits more like interchange between the data scientists at the company in terms of new tools and ideas. But I'd say that the key point is really the interesting problems.
Well, data science really starts with data, right? And most data scientists really are bees looking for insights. In many ways, they really search for truth. They're also very the default opinion of a data scientist is a no, right? The sound of no is what you hear from them. And we grappled with that problem early on as well. We would have a chief data scientist resign every 3 months, mostly out of frustration because the software engineer's default position is a yes, right? And you have this good fusion of software engineers wanting to build something and data scientists want to deconstruct it. So it's kind of like the yin yang of an organization. And I think what we're beginning to see now is the first time products that actually talk to both. I mean, H2O is an example of that, but a lot of new products in the space can actually talk to them both on each side and then make it a product problem as opposed to a people problem. So it's usually asking the right question problem as well. If you ask the right question, then you get the right, kind of ABCD answers for it. In fact, most of our software engineers who wrote random forest, for example, in the early days, the first slide would be, I am not a data scientist, would be the first moniker on their slides, and kind of taking that punch into that space. When we were dealing with compute as a scarce resource, we were computer scientists, right? And now you have data as a big problem, and I think it's imperative for most all of us to become some form of data scientist, actually.
And the follow-up for you on that is, what can a company like us do? I mean, what are the features we can add to democratize data science, to bring in citizen data scientists? I mean, if that's one of the approaches we could a vendor could take, and what could we do to bridge the gap?
Well, a lot of people take quarrel with citizen data science at all by itself, and there was this hugely popular KD Nuggets article on how to find fake data scientists, right? And part of that was like citizen data scientists clubbed together as people who are analysts but not data scientists, and so on and so forth. I mean, kind of the making them look smaller to some degree. So I think it's an interesting question for the panel if they do believe that citizen data science is possible, or is it yet another BI wanting to be data science mindset that Silicon Valley created.
Charles, you wanna? Oh.
No, so I think one of the things, and this is both in terms of how do you, so attracting data scientists is one problem, but actually retaining data scientists is kind of like a second order question of, like, having interesting questions is all well and good, but if you don't ever actually get to do anything with those questions or see somebody actually taking the results of what it is that you did, then it's a pointless gesture. And so one of the things that I think that we're making advances on, I think, like the entire community, but where products like H2O that pushes out a Pojo or something, I know of, so a former colleague of mine who had been with his previous company for 5 years before he saw a model that he built get implemented, right? And now that may have only been 2 models because they weren't the quickest companies, but no, so like 5 years of work that didn't ever go anywhere, right? And I think we've probably all felt that. We've all built something that didn't actually get used or didn't get appreciated, that just sat on the shelf. And so, as we make it easier and more meaning, for people to push out and actually see the meaning of their work being consumed, that I think is where as the environment continues to grow and evolve, that there's a lot of opportunity to make it so that more people are wanting to be engaged with it. I don't necessarily think that it's like, I don't think that the base question is how do we make it easier for everybody. I think it's how do we make it easier for data scientists to actually have meaningful impact on their organizations.
Yeah, that's an interesting point. I mean, Charles, is it possible to have a citizen data scientist? Is it really possible for a layperson or an analyst to do data science, or should it be left to the experts?
I don't know if I'd call it a layperson necessarily, because we're talking about fairly technical people regardless, but I think it's certainly possible to have some of the tasks that are currently labeled under the data science heading be moved onto technical people that aren't necessarily data scientists. So you don't need all the same skills that are currently associated with data science to do many of the tasks that data science currently do. So,
maybe another way to think about it is, my C and C# are not great, or C++ as well. And so many, many years ago, I probably wouldn't be anything close to a software engineer, but I can do a few things pretty decently now. And I think if they can teach like Java or Python on the middle school level, it's there's this gap that's been closed a little bit. It's no longer tools as a barrier, it's now tools as an opportunity. As the tools are more accessible, even if they're accessible for the people who do it as their job, that means that there's this sort of eventual trickle down, which is kind of cool.
Yeah. So that also sort of brings to the next sort of logical question is when we are talking about the data-driven organization, you have data scientists, the developers, data engineers, DevOps people all working together. Is there a need for, a common platform like a GitHub for data science, or are existing tools good enough? I don't know, maybe start with Tom.
Well, kind of the definition of people that build tools is existing tools are never good enough. You always want more. But I think that a lot of progress has been made in this area. Just over the last several years, especially in the open source, there's been a dramatic increase in what's available for people, which I think is great. And I think what's kind of missing is that kind of next step to be able to deploy stuff, right? That making it easy to deploy stuff is kind of that next boundary is, as far as what I can see in working with lots of people. And like that's what everybody's asking from the last year or so is now how do I deploy my models?
Brian, do you have a take on?
Yeah, and I think along those lines, I think the H2O Pojo is really kind of a good step along those lines. Then kind of how do you add that higher order logic on top of it that says this is a model that was built for this specific business process that works within this context? How do we version it? Kind of maybe it is the GitHub approach, but how do we kind of add that metadata layer on top of that?
Yeah. How do you bring kind of more of the... It's actually almost like how do you bring software engineering practice to data science, right? And vice versa. How do you bring data science to software engineering practice, and how do both communities learn from each other? I think that the other challenge we typically see is a third element, which is where probably Brendan was headed towards, is how do we bring D3 or JavaScript into this, right? How do we bring kind of more of a application developer, like not just the systems developer. So what we did at H2O was integrate first the systems engineers with machine learning. They looked at machine learning as if it was an application to build, from a kernel engineer up, right? But what we are now beginning to see is, of course, now that you have H2O and there's all this NSpark and all the systems engineering to drive machine learning, how do you use machine learning as the next layer up? How do you use app developers to now jump in? And I think that is bringing design. So the confluence of design, data science, and software engineering, assuming that the data stuff is all covered, big assumption, I think that's kind of where we're going to see the next kind of simplification. So there is no there's no free lunch, right, as Mark Landry likes to say. But there is definitely simplification that will lead to vibrant applications. And those application developers will take these things into lots of millions of things, millions of internets of things. And so I think that's kind of where we'll see kind of the next real democratization.
Yeah, and I think it's a fair point. I mean, so one of the ways to define how does the rest of the world use machine learning or data science? It is via a smart application or a data product, and we have talked about this all day long. But and Tom touched upon this. I mean, one of those examples was journals.ai, which he demoed. But how do we take the machine learning applications to the business users? I mean, and that's when the real value is. I mean, when you go to production, what does that mean? It means someone is using it, making business decisions based on that. And what does it take for the end goal? I mean, the full end-to-end implementation. Maybe start with Brian again.
Well, I think to the point earlier is you got to get wins, and wins usually mean in production, and they're tied to business value, some sort of KPI that moves the ball for the organization, be it new revenue, cost reduction. You have to have wins in production. I think it goes back to some of the things that Jeff talked about in terms of that. What's that MVP that really is going to take you from this thought into something that actually run in production versus maybe something that's over-engineered that does take 5 years to get in. But I think focusing on those wins and aligning those wins to business KPIs is really key.
I think one of the things, both in terms of how effective we are in pushing products out, is that actually creating a data-driven organization isn't just having a smart data analyst, data science, whatever you want to call that group. It's not just that, right? If you want the whole organization, you're meeting somewhere in the middle. Yes, we can take the applications we're developing and make those more accessible, but I think to your point earlier, right? The layperson is never going to necessarily be able to consume all of the richness of the data products as you're moving more into big data, machine learning type applications. And so, I think one of the big shifts that I think that companies will really have to make if they truly want to be data driven is, if you want to have, from a marketing perspective, right? If you're talking about having smarter salespeople and smarter marketers, it's not just giving them better applications, it's actually hiring salespeople who will consume what you're giving them and are coming from a data driven perspective. So there is no one size fits all answer to kind of bring to that, but it's not just we make everything completely accessible and then that will change the world. The world also has to come to us a little bit, and organizations, and so part of that is that higher level. You have to have your senior level buy-in, but that's not just senior level buy-in who's going to sponsor your team. That's changing how HR hires. That's changing how you train people. It has to start. We can be the kind of locus of that, but it has to be an entire organizational shift.
In terms of marketing, I mean, that has become a pretty flat, horizontal, pretty much. I mean, it used to be marketing was really what you got from Wall Street, or you go to New York to get a good marketing consultant to build brand. I mean, tell us how data has changed marketing for you guys.
Well, certainly, marketing spend ROI is more and more important to Catalina's clients. So to reach the highest ROI, you need to pick the best audiences, and the best audiences are normally picked by the best algorithms. So, kind of if you look across ad tech space, you have relationships with, we have a really great network. We have relations with advertisers, but at the end of the day, you're seeing this competition of algorithms where everyone needs to get better.
And at Allstate, are you guys doing a lot of marketing algorithms as well? Or?
Yeah, we have worked with both the marketing and with the regular sort of traditional insurance data science, the rating plans and retention and the like. And we work with both groups to try and inform. And the idea is definitely that the entire organization should be making decisions from a data-based standpoint, which really does require buy-in from the other areas, that they should be doing this and that they can alter their procedures so that it actually gets embedded in their standard workflows that they use data.
I actually do have an anecdote for Allstate. They are the reason we first came to Chicago 4 years, almost 3.5 years ago. And Mark Slusser put us up on one of his slides for Strata as well in the early, maybe the first few months of the company. So, I mean, I was amazed to go into Allstate's lobby, and they had the first car they insured in the lobby. And I was like, wow, this is a company that really cares for its customers. So we took a lesson of that, and we have all the contracts. And one of the first ones was Allstate. So we're so happy to be in Chicago again to do this event. But thank you for inviting us to the city way back when no one knew us. So.
Can't take personal credit for it, but.
Cool. One other question. I mean, so one of the things we keep hearing again, the artifacts of data science. I mean, you have the data, the models, and the scripts. And so a lot of times the reason there is inertia in a company or in an organization to move forward is because the models are not interpretable. The data changes. There are concerns about data governance and concerns about how the models are adapting. How do you solve for that, and how do you communicate that even better? I mean, that's probably more important. How do you assure your business users that we have taken care of the model, data governance and the model governance? Maybe I'll start with Brendan.
Yeah, it's a great question that we're still kind of struggling with at Capital One, what this interplay looks like. Because on one end, you can restrict yourself and only use logistic models where it's very, very interpretable, but you're giving up a lot of predictive power. And on the other end, you can sort of just not really care as long as you have really great predictions and you can bootstrap or something like that. And it's a really hard line to draw and say, well, how much is interpretability worth to you? Is it 1 million, 10 million, 100 million? And if we can have much more actual and much more powerful models that are slightly less interpretable but actually perform a little bit better, where does that trade-off lie? And it's a question that I think folks aren't really used to asking or to understanding. And with kind of having more powerful tools, it's very exciting to be able to provide new insights or new predictive power, but it's definitely a different kind of worry that you have to think about. And as the data goes through, it's also kind of interesting to think of, how often do you retrain? Or, what if our input parameters drift a little bit? These are new kinds of questions that I think a lot of folks are just thinking about for the first time. So it's fun, it's exciting.
I think there are places we can see examples of where that's happened already, though. So my team will probably groan that I bring this up for like the N millionth time. But so I used to be a meteorologist, and I think that is a space where the intricacy of what actually happens within a weather model, while I may technically have the skills to disaggregate that, I never cared because my job was I was a forecaster, right? So I only cared about the outputs and being able to interpret the outputs. I didn't need to know what was happening in the intricacies of it. And at the same token, I got a new model every 6 or 12 or 24 hours, depending on which one it was, because I knew that whatever the underlying conditions were changing. So I was always, where's my next model run? Where's my next model run? So there are places out there that have made that shift from I'm making all the decisions and I know what all the inputs and outputs are and what's happening in between. And they've moved to, I don't know what to call it, black box, right? But interpreting models, you're interpreting output, not trying to understand and interpret the model itself. So there are places that has happened in a lot of industry and business. Since this is new, it's changing. We're on the front end of that journey, but there are places where we can kind of see where that's already happened and hopefully take some learnings from.
And I think maybe variable importance can maybe mitigate a little bit of that black box nature of algorithms. And I think for us as well, if in a marketing sense, if you're generating an audience based on this model, can you describe or build a story around that audience that's produced based on that model to help gain some comfort with that model?
Charles, do you have a take on what you guys are facing?
Well, to some degree, the problem can be constrained in the regulatory space because the question of how do we trade off interpretability is answered by departments of insurance who say, well, no, you need this much interpretability. But there are other models where that's certainly a discussion with the business partners. And I think it's an ongoing conversation.
And I think open source also adds kind of an interesting niche here, because if you want to, you can sit down and understand how GBM works in a couple of different frameworks and see if you can support those. And that's a different kind of interpretability, to be able to trust that this code is doing what it says and it's distributed in kind of a smart way. And it's fun if you haven't sat down and like read through neural networks and H2O. It's a good afternoon if you're willing to go through it. It's not too awful. The comments are good, I promise. But it does add to a little bit of trust that you can sit through and understand, well, I've got a tree-based method, no value comes in, which way is it handled, and see that directly and affect it if you need to. So,
I think it's, speaking for customers, of course, of other credit card companies and banks, really, where regulation really makes a big dent into this interpretability. I think what regulators are really seem to be looking for is the person who's behind this trustable, right? As opposed to, I mean, the five-letter word trust, which you just dropped. I think that's really what they're looking for, whether it's FDA trying to see if our models are trustable or regulators from the banking industry. And I think once they begin to start opening up for models that are now in true open source like H2O or R, in Python, I think then you begin to see more of that adoption. GBM has like crossed that. I mean, GLM was the only benchmark for this, but now GBM has crossed over into public adoption and acceptance by regulators as well. So I think that's and I think deep learning is waiting on its wings, I would say. So it's only a matter of time before the people who are regulating this space will also begin to like find trust in these models. But models are really hard to debug and test. How do you like know that the model's not gone wrong?
Arno is really responsive sometimes. Kudos to him. And it's not so much debugging as understanding. So there are many, many optimizations that can be made all the way along. And so for me, it's not necessarily debugging, because to be quite blunt, you guys do good work. And it's more just checking out and understanding, and then being able to use the code base as a way to explain to my peers, hey, this is what's going on. I can shade out GBM and what that looks like really quickly, but to be able to sit and look at the code, even if someone isn't quite understanding it, seeing the code itself adds value, and it adds a bit of credence, and it adds a bit of trust, to use your word.
Well, and I mean, to be honest, like we're never really building a model to solve a question we've never solved before, right? So there is a certain amount of knowledge and heuristics around like, hey, the model's saying something that is really unintuitive, let's dig in. And it may be that that's actually the right answer, but I mean, there has to be a certain amount of like business domain knowledge in like actually debugging the model, not necessarily the code of trying to figure out what's actually happening in it, but like, do these results make sense? If they don't make sense, why not? I'm completely willing to change my mind, right? But like, you can kind of get that first sense of like, does the model actually seem like it's doing what it's supposed to do? If not, then let's spend time digging in. But like that, you kind of have to have some of that previous, like that, those heuristics built in already.
The feedback loop.
I just also want to open up, if somebody in the audience has a question, I would like to bring it in. And if not, I'll continue. So we have just a few minutes left, and I just want to go around and ask, hey, what's the coolest stuff you're looking at, and something that's caught your eye in the last recent past, or something you might be working on and you want to share with us?
Certainly, I think for us, real time and being able to compete on algorithms is really kind of the key focal point for us. Using more data in terms of both in terms of the observations and the width of data and more sophisticated algorithms, and really pushing that to real time, making the decision at the point of contact, the touch point with the consumer is really that's really where we're heading executionally.
Johnson.
So for me, I think it's really the speed of the creation and the whole process of creation to implementation. Because some of the models were just, the previous iteration of doing them took like 6 months or something. And if that's the process, well, then it's a big investment of resources to do a new one. Whereas if you can shorten that down to like a couple weeks, then it's more reasonable to update quite frequently and keep it more accurate.
I would say visual machine learning, of course, is something we are really chasing. One of the questions I left out on my keynote was, how do AI programs meet for their data science community congregations like these, right? How do bots meet and exchange information? I think, and I left out the answer because maybe they're already meeting and we don't know, right? So I think the key here is that improving information exchange between different communities. Like healthcare, for example, they use one of the least effective measures in the entire industry, and the side industry like insurance or banking use the most sophisticated measures and metrics and algorithms. So I think cross-pollinating these ideas, especially as customers of H2O and the communities of H2O, we're able to cross-pollinate these ideas and take one from the other, and maybe even have people sit together on a panel and exchange how the culture of doing data science in one space can impact and save lives in another. I think that's kind of something I'm really excited about.
Yeah, I think to build on that, I think there's a great movement towards integration and sharing in the data science space. And even the R versus Python religious war seems to be dying down just a little bit, hopefully, where now there's solutions where you can sort of integrate across both, or better integration across Hadoop products or things like that. So you don't have to pick a stack that one person has built the entire vertical. You can now pick and choose your pieces. I think that just brings to a stronger solution across.
So I'm with Brendan there, right? Like I think the move towards more open source platforms, the ability for us to use, like I enjoy SPSS and SAS and some of those old kind of like those whole packages, but the bar for entry is very different now. And so, you don't have to rely on multi-$1,000 licenses to be able to do this stuff. And so the speed at which things are moving, I'm not waiting for a company to release a new package or to, update, to 9.15 or whatever, right? It's no longer annual updates. Now it's weekly, it's daily, and so it's a whole different set of challenges, but it's new challenges, right? It's not the same problems. We're solving new problems, and I really do think that that's an exciting, it is, it's a lot of fun.
Tom? Makes kicking the tires a lot easier.
Yeah,
that's true.
Very much so.
Well, what's always been really exciting to me about being part of H2O is getting a chance to look at lots of different problems. Like, a number of you guys have mentioned that it's really interesting to look at different tools. But for me, being a software engineer by trade and being at H2O, what's really interesting for me is being able to look at lots of new problems and being able to apply this broad concept of math and machine learning to lots of different problems. And what I look forward to is being able to take kind of this next step that we're taking with visualizations and being able to look at lay people and think of them as domain experts instead of lay people and actually be able to reach them. And that I think has just incredible potential.
It's the era of domain science ahead, right?
Yes.
As data science becomes more general and everybody's tool, I think domain science will come on and become more effective as a change.
AI frees us all up to be more creative, do more fun things.
More human.
We're getting to work on new problems too, right? Like the new tools, the new stuff that's out there, that's allowing us to tap into problems that are companies that we've never been able to tackle before.
Before.
So,
yeah,
absolutely.
Thank you all for the wonderful panel. I'd request the audience to give a warm round of applause for all of our panelists.
Thank you.
Thank you.